Okay, we are dealing with a 2013 3/4 ton Silverado with these codes. The most important of which is the P0641 5-volt reference 1 circuit. And I've got some of this info printed off here. So the 641 refers to 5-volt reference 1, which is a 5-volt circuit that provides 5-volt feed to the oil pressure sensor, the fuel rail pressure sensor, the AC refrigerant pressure sensor, the exhaust pressure differential sensor, and the camshaft position sensor. So I've got an OE diagram printed off here, and you can see there's 5 separate wires that run out of the ECM to each one of those sensors, and that circuit is actually bussed together inside the PCM or ECM. So what makes this difficult to track down a shorted reference is they're not shared outside of the ECM. So I'd either have to get access to each one of these or unplug all the sensors. You know, you waste a lot of time messing around with this. So I'm going to demonstrate how we solve this issue quickly and efficiently, and then how we verify that it's not the ECM failing, that we actually have a shorted sensor. Or in this case, this is really unique. Why I wanted to document this is this actually has 2 shorted sensors on the same circuit. So this is a really unique situation. So I just wanted to run through how we got there and how we got there efficiently. So I'm going to set you up on the truck with the Snap-on Verus, and I will demonstrate what we have going on there. So what we're dealing with is so I have on the Verus, what I'll have is the voltage monitored at the AC pressure sensor feed. And then the sensors that are shorted are the oil pressure sensor, which luckily there's an inline connector right on top of the engine going down to that, and I'll show you that. And the fuel rail pressure sensor is also shorted, and I'll show you all of that and how we determined that. Okay, now we're on top of the truck, and I have just over here on the right side of the screen, I have a lead back probed into that 5-volt reference at the AC pressure sensor, which is right here. And then this lead here, this inline connector, goes to the oil pressure sensor. And then way back here, this tan wire is the 5-volt for the fuel rail pressure sensor, and this gray lead here goes down to the oil pressure, and that's the feed for that. So first I'm going to demonstrate how we figured this out quickly and efficiently, and we did that by tracking just the voltage, which is the green trace on the scope. And I have the digital feed up so you can see I've got about 160 millivolts right now on that circuit, and that's with everything connected. And you can see here, I'm going to just unplug this inline connector. Maybe. And that voltage actually went up just a little bit to 190 millivolts. And now what I'm going to do is unplug the fuel rail pressure sensor. And there you can see the voltage shot up to just under 5 volts. Now watch what happens when I plug back in the oil pressure sensor. It goes down to about 800 millivolts. So we have 2 shorted sensors, and that's how we proved it. So now what I'm going to do is demonstrate how we can prove both the sensors are shorted and there is current flowing from the ECM to those sensors, and it's not a failed 5-volt converter or resistor or diode or anything in the ECM causing this. So that's what I'm going to demonstrate now, and we're going to start. The yellow trace is current flow, and what we're going to do is we're going to start by measuring the current flow at the gray wire, which is the 5-volt feed on the AC pressure sensor. Here you can see when I clamp it on there, we have about 5 millivolts, or 5 milliamps, sorry. So we have about 5 milliamps on that circuit feeding the AC pressure sensor. So now if I clamp this over the gray wire going to the oil pressure sensor, you can see we have about 200 milliamps, which in my opinion is way too much for a sensor feed. And I want to show what happens when I plug in the fuel rail pressure sensor. You see that current flow actually dropped to about 27 milliamps, and the voltage dropped even more on the 5-volt reference, down to about 170 millivolts. So now what I'm going to do is move that amp clamp over to the fuel rail pressure sensor. You always want to make sure that's reading 0. So we'll make sure we zero that. And we'll clamp it over here. And you can see we have about 168 milliamps there. But since these are sharing the circuit, when I unplug the oil pressure sensor, you can see the current goes up on the fuel rail pressure sensor to about 200 milliamps, and that voltage stays really low. So we know that both those sensors have the capability of pulling that voltage low, and we know the 5-volt reference out of the ECM has the ability to provide around 200 milliamps, but it's losing voltage at that current flow, which seems reasonable. So I'm going to condemn both these sensors to fix this vehicle and repair that circuit. So that's how we prove what's going on here, is that the current is actually flowing through the sensor to ground and pulling that 5 volts low on that feed circuit. And you can see I'll reach back here. As soon as I unplug this, the current flow goes away. Yeah, the current flow goes away and the voltage goes up, and we're back to 5 volts. So now I know whether the oil pressure sensor is plugged in or the fuel rail pressure sensor is plugged in. Both of those will pull that 5 volt reference low, and we don't want that. That's what's causing that code. And we can go a step further and prove that the computer knows that it's fixed. Here we have live data showing reference 1, reference 2, and reference 3 all okay. And you can see as soon as we plug one of these back in, that changes to fault. So the computer knows that that's being pulled low, and that's a problem. So go ahead and plug this one back in. And you can see how that current flow is what's pulling that voltage low. And you can see that clearly on the scope. That's what I wanted to demonstrate. Even though these all seem to be separate circuits, they're bussed inside the ECM together. So if the voltage is pulled low on any one of those 5 circuits, then you can see it and measure the current flow at each sensor to determine which sensor is causing the issue. Or like this, we made it really efficient by just disconnecting each sensor while monitoring voltage, waiting for that voltage to go high. And then when it does, you know you have your short, but you still have to confirm that there's current flowing there. And you know, typically the 5-volt reference can handle about 100 to 150 milliamps before it starts to pull low. But anything over, say, 50 milliamps really should catch your attention, because it's not typical that it would pull that kind of amperage or current through a sensor. The sensor's just there for reference voltage, essentially, so it's not really manipulating that current. It is at a very, very, very low current, and that's something that we struggle to measure with these tools. But when we have a problem, we can measure it. And that's how we can do that. You can see that current's high on that fuel rail pressure sensor. The voltage is low. I'm going to come back over here. Grab that gray. And you can see we have about 38 milliamps there. And then once we remove the main shorted sensor, the one that's shorted in the worst way, which is the fuel rail pressure sensor, you can see that oil pressure sensor is still pulling, you know, 212 milliamps, and that voltage is pulled pretty low. We're at about 800 millivolts. So I just wanted to demonstrate that. This is a pretty unique issue to have 2 shorted sensors on the same 5-volt reference, but that's why it's here, is because it's a bit of a nightmare situation. So I hope you learned something from this. Thanks for watching. Appreciate it.